Yep, I do. So D and E, do it on your own.
Okay, so cosecant 5 pi over 3 is 1 over y, and
Okay.
it'll be 1 over negative square root 3 over 2.
So do you say this is 1 over what? Y, right?
Yep,
And what is y in this case? Negative. So it's 1 over what?
negative square root 3 over 2.
So you cannot leave it like that.
And then so it'll be negative square root 3 over 2.
No, this is 1 over.
I don't know.
What's the meaning when I put 1 over? 1 over means what? What are you gonna do with this fraction?
Times it.
You flip it.
Yep.
So what happens when you flip this fraction?
2 over square root 3.
Mm-hmm.
And then we gotta rationalize that.
Mm-hmm. So don't forget, 1 over means you reciprocal the whole fractions.
Okay. And then it'll be, yep, and then over 3.
Do tangent. You did that already?
No.
Okay, try that.
So is it negative 1/2 over square root 3 over 2?
Where is negative 7 pi over 6? What quadrant it belongs to?
Is it in a third quadrant?
No, it's a negative.
Oh, negative. In the second quadrant?
Which second quadrant is correspond to negative 7 pi over 6?
5 pi over 6.
And tangent is what over what?
Y over x.
Do we have a coordinates for, do we have a value for y over x?
Yep.
What was that?
1/2 over negative square root 3 over 2.
And what do I put underneath that is the y over x?
So it would be negative square root 3 over 3.
Come on, Calvin. You're gonna do this now, like. Right. Now cosine 900 degrees. So you minus 360, very good. You minus 360, very good, means you get 180, right?
Yep.
So what is cosine 180 degrees?
-1.
Okay, so far, everything you did here is not inverse. They're all sine, cosine, secant, all these things. But now we're gonna do the inverse, okay? So how do we do the inverse in this case is you have to read backwards. So this might be right. So when you look at the arc cosine of negative 3 pi over 2, this might be right. So so when you do the cosine of 3 pi over 2, so again, when you look at this, you look really backwards. It means your answer is in radian or degrees. That's correct here. So where is negative 3 pi? So cosine is x or y value?
X.
X. So can you tell me which x value here give us negative root 3 over 2?
Um. 7 pi over 6.
And
I said that 7 pi over 6.
yep, and you got two answers. Forget
5 pi over 6.
yes. Okay, so this is wrong. Now, since you got two answers, 7 pi over 6 and 5 pi over 6, which one are we using in this case is, do not forget that every time when you do the cosine, you take quadrant 1 or quadrant 2 only. Where quadrant 1 in this case is positive and quadrant 2 is negative. So which one is your answer in this case? Your answer in this case will be
Quadrant 2.
Quadrant 2. So in this case will be 5 pi over 6. Okay, this is just only for cosine. So the arc cosine. Okay, so this is very important. So when we talk about the arc cosine, you know, this angle has to be in quadrant 1 and quadrant 2. But if you talk about arcsine or arctangent, this angle will be in quadrant 1 and quadrant 4. And you find out that everything here has a quadrant 1 is because for all quadrant 1, everything is positive.
Yep.
And in quadrant 4 or quadrant 2, this will be negative.
Okay.
So in this case, oh, this one will be correct. Arctangent, so of root 3. So again, Kelvin, if you see root 3 for if you see tangent, you look at y over x. So can you tell me which y over x give a square root of 3?
2 pi over 3.
And well, this one doesn't know. This one doesn't give me square root of root 3. Oh, sorry, root 3. This one doesn't give. This one doesn't give me root 3. This give me negative.
Oh yeah, so it's pi over 3.
So this is wrong. So in this case, square of 3 in this case is pi over 6. So it's not pi over. So this is pi over 3. Now the reason why that we don't use the 4 pi over 3 is because this is in quadrant 3.
Yeah.
Okay, so now, so this is for the inverse. Now what happens if they are the same? The tan, arctan, sine, arcsine, they will, yes, they will cancel each other out. So what you get here?
Negative 1.23.
But don't forget that if you have, so when you do, the next one we talk about is this tan and arctan that we talk about here. So when you do tan and arctan of a number, your answer will be just this number. They will cancel each other out. But what happens if you have arcsine, sine and arcsine of a number? Or cosine and arccosine of a number? Can you just cancel this and write this number down here?
Oh.
No. So this number has fulfilled the range. And what is the range for sine and cosine?
It is negative pi over 2.
No, the range, the domain is from -1. Sorry, domain is from -1 to 1. So if you have a negative 1.23, this answer, if you have a sine and arcsine, sine arccosine, you got do not exist here. You got what I'm trying to say here?
Yes, that makes sense.
Okay. Same thing here.
But that's tangent though.
Yeah,
so
tangent works.
Oh, okay.
because tangent, the domain for tangent is all real numbers.
Yep.
So that's why any numbers work. But for the sine and sine, cosine, and arc cosine, your domain is from -1 to 1, so you have to watch out. Same thing with J, the sine and the arc sine and sine will cancel. So your answer in this case is 5 pi over 3. However, if you refer back to your arc sine in this case can be only found in what?
Quadrant 1 and 4.
Quadrant 4. So where is 5 pi over 3 at?
In the 4th quadrant.
In the 4th quadrant. Then why this answer is still wrong? We say, well, David, is quadrant 1 and 4, right? This is in quadrant 4. So why? It's right here, right? Why is still wrong? The reason why that this is wrong is because that the answer that, I'm sorry, it has to be negative. So can you tell me what is the 5 pi over 3 if you go clockwise? What is this is 5 pi over 3, right?
Yep.
Can you tell me what is the one that negative go clockwise?
Negative pi over 3.
Yep. So I just want to, so this answer will be negative pi over 3. So really brush out this page because this is the one that a lot of students get wrong. Where do you brush out? Do you still got the quizzes I sent it to you?
Yes, I did them too.
This is so I would recommend that just practice this.
Okay.
Okay, this is the one that I was like, yeah. Don't forget. So this is graphing now. So we're gonna talk about graphing here. So weird that you do so well on the first page and then slowly it progress.
It's because that's when it's just like my brain is just
Your
like
brain. So don't forget when you do tangent and cotangent, your period in this case is not 2 pi over b. It's just pi over b. Yes. Okay, this is correct. What you did here is correct. Okay, the ABC is correct. So the only thing is wrong here is we don't use 2 pi.
Okay.
So what is your period in this case? Your A is negative. ABC is correct. ABC is correct.
Oh, okay. It will be pi over 2.
Yep. Phase shift is C over B. So in this case, this is correct. Pi over 4. This is correct. Vertical asymptotes. Very good. For cotangent, it's 0 to pi. This is correct. This is nice. You move that and then you divide. Oh, this is nice. Yeah, this is nice. Plus pi over 2 divided by 2 will be pi over 4. Yes, very good. Where you get the 6 from?
I have no idea.
So this looks correct, but this is a little bit wrong here. So it's not 6 pi over 4. Should be what?
I should be dividing by pi.
No. Yeah, when you divide. So what happens when you take 3 pi over 2 divided by 2? What you get?
Then 3 pi over
4.
Wow.
You need to get this one right.
I should have got that's like the most stupidest mistake.
Okay, now this one is okay. So now we're gonna graph. So I'm gonna teach you how to graph again. So so we're gonna look at your, so what you did here is your vertical asymptote is very important. Okay. So so you will have a pi over 4. So pi over 4 is over here.
Yep.
And then 3 pi over 4 is over here.
Yep.
So I'm gonna use, guess what? I'm gonna use this graph paper because, so I'm gonna do the little dot. So this is for the asymptotes. So this is pi over 4.
Yep.
Okay. This is 2 pi, 3 pi over 4. So 3 pi over 4 is right here. Because they are a quarter, 1/4, another quarter, and a quarter. So if you look at this, this is pi over 2. Because a quarter plus a quarter is a pi over 2, the period. Yep. And then if you, now you're gonna do all this dot, 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 dot for your, this is your asymptote, right?
Yep.
Okay, so it's just like this. And now your cotangent, can you tell me what is a cotangent graph looks like originally?
It looks like a little line.
Oh, it's line. I don't know what line.
No, like this.
Is that gonna be like this or it's gonna be like that?
The second one.
Okay, this is a cotangent graph. That's correct. Now, so what is affecting this is your B, your A, sorry, your A. Because your A has a -1. So what happens is originally right in the middle is 0, 0. Right in the middle of the middle is 1. And right in the middle of the middle is -1 on the other side.
Yep.
So what happens with this, since your A in this case is -1, so what happens is this will become -1. This is still 0, and this will become +1. So your cotangent graph in this case will look something like this. So this cotangent graph will be right over here. You got what I'm saying?
Yes.
So this will look like him, and it will cross at 0, 0. And then this is also will cross at 0, 0. So the other line will be something like that. So this is your cotangent graph for number 4 here. And it depends on your A. You're right there, Calvin.
Yes.
Okay. Now we're gonna talk about your next one.
Wait, but you asked for 2 periods, right?
Yep. Two periods. That means you need to draw another one like this, and then draw another cotangent graph.
Okay.
This is the meaning of 2 periods or 2 cycles. This one. Number 5. This is a secant. So you do the cosine graph. That is correct. Amplitude is 3. This is correct. 2 pi over b. Sorry, I need to move my thing over here so I can see much better here. So a is 3, b is pi, c is -pi over 2, and d is what? It looks like good here. So 2 pi over b, 2 pi over pi. Where is this going to be when you cancel?
2.
Yep. Phase shift is this over that, -pi. This is not -2.
Oh, I had a brain fart. Okay.
So what is negative? So when you do your phase shift,
Yep.
is -pi over 2 over pi, right?
Yep.
So what happens? So this is -pi over 2 divided by pi, which is same thing as what?
Times
Times with what?
1 over pi.
1 over pi. So the pi and pi cancel. What you get?
-1 over 2.
Okay, so this is wrong. Okay. All right, the rest, this is good. You just need to finish out what is the last one. Can you tell me what's the coordinates for the last one?
We just add pi.
No, the original points. You only got 4. Where's the last point? You'll be 2 pi and
0.
1, right?
Yeah, sorry.
Okay, you're missing that one. So this is good. And you're gonna say, yeah, this is good. Yes, 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 yes. This is correct. Yeah, this is correct. And then you divide by pi, right?
Yeah. You can tell it's starting to like, I do less and less and less.
And when the same thing happens, what happens when you divide by pi?
You times by 1 pi.
And what happens when the pi and pi cancel?
You get -1/2.
This one. So let's do this one.
I know you got a -pi/2, and then you got to divide by pi.
Pi x in this case will be what? When you subtract 2 pi from pi/2.
It would be 3 pi/2.
And then what happens when you divide by pi? So imagine you put a 3 pi/2 here. You got a 3 here, right?
Yep.
Then you divide by pi, right?
-3/2.
So x in this case is -3/2. Yep. So that means that this starts from, I'm going to draw it over here. I'm going to write the final points here.
Okay.
So it starts from -1/2. And it ends at what?
-3/2.
Not negative, positive. Oh, sorry. Because this is a this is a positive, right? Sorry, this is positive.
Oh, okay.
So this will be positive 3 pi. Sorry, because it cannot be negative.
Yep.
Why I say it cannot be negative? Because this is a smaller one.
Yep.
That ending point cannot be smaller than the starting point. You know what I'm saying?
Yeah.
So when I say negative, like something wrong. All right. So what you do here is, what's the next thing?
You times it by 3.
How do you figure out what is your next coordinates point?
You do 1 times 3.
You take the period and divide it by
4.
4. So you can tell what to add. And what is your period in this case? Your period is
2.
2. So what is 2/4?
2.
Huh? No calculators. 2/4. 1/2, right?
Yeah.
So what can you add? -1/2 plus 1/2?
It's 0.
0 plus 1/2.
Half.
Half plus half.
2.
Half plus half.
1.
And 1 plus half.
3/2.
So you got this. So this is how you figure out your final point for the x value. Now, how do you figure out your final point for your y value?
Then you times it by 3.
You times it by 3. What else?
You add 1.
Yes. So you take all this x value, y value that you get here. So this is 1, right?
Yep.
So what is 1 times 3 plus 1?
4.
0 times 3 plus 1?
1.
-1 times 3 plus 1?
-2.
What's the next one? 0. So 0 times 3 plus 1?
It's 1.
And then 1 times 3 plus 1?
It's 4.
4. So this is where you will graph. And don't forget, this is your cosine graph. So you will have 1, 2, 3, 4. So the first one is what? -1/2 4.
4. Yep.
0 will be where?
0, 1 right there.
1.
1/2 and -2.
So something like this.
Yep. And 3/2 is 4.
So back to 1.
Oh yeah.
And then 3/2 is back to 4. So you get yourself a cosine graph.
Yep.
And this is not your answer yet. And I need how many cycles?
2.
2. So you just duplicate this. So the next one is 2. It will get back to 1. And then the next one is 5/2. You get back to -2.
Yep.
3 get to here, and then 7/2 will get back to here. So this will be a 2-cycle graph, which is I want you guys to draw. But this is the cosine, right?
Yep.
I want to draw the secant of this fellow. So what is a secant graph looks like here?
The opposite of the.
So you need to give me your asymptotes. Where is your asymptotes here? The horizontal asymptote is at where?
At 1, but now I moved up to 4.
No, the horizontal asymptote is at 4. And use 4. And where else? Yep, you're correct. I'm sorry.
-2.
Yep. So these are your horizontal asymptotes. Now, where is your vertical asymptotes at?
Right where it crosses the x-axis, right?
This right here?
Yep.
No, that would be right. Where is your
Yeah,
vertical?
1
Where at?
right on the y-axis, right?
Right on the y-axis, that is correct.
And then at 1, and then at 2, and then at 3.
Yes, that is correct. So that is your 2 and then 3. So where is your secant graph now? So this one is a valley, so you become what?
A hill.
Here, or open downwards. This one will be open up, and open down. And how many do I need if I want 2 cycles?
4.
4. So you just need to do another one here, or some, some. This is your graph. Can you do this?
Yeah, so what confuses me is like making all those extra points after the first 2. So if I just, doing that.
Keep on going. I will say that keep on going, don't give up.
I know.
Because you will still get points here.
I mean, at least I did most of it right.
You started right. You just have a, looks like when I look at this test, it looks like I have a second guess yourself.
Yep.
Now we do some proving.
I hate this stuff.
I mean, why you hate it? You have to do this. Don't give me that mindset here. I don't want you to give me, I hate this stuff. You're going to see a lot of provings. So where do you start?
On the harder side.
Which is harder in this case?
The left side.
Then why you start on the right side?
I don't know.
So what you do here?
You times divide secant x minus 1.
Why you don't do it?
I don't see. That's why I said it. It's just like.
Why you don't do this?
I don't know. I told you I just have.
I do not know either. And what you do on this side?
You do the same thing, but it'll be the positive, right?
Okay, you do it now. Go do it yourself. Because I'm not going to show you all this work because, boy, in your test, why you don't do it? You got this idea. This looks good. The 7 looks good too. Again, you're not finishing it. That's why. You know how to do it. It's just like,
I know. You don't have to tell me. That's why.
I'll look at your number 9 while you do your number 6.
Okay.
Yep. Nicely a bit wrong, but it's not bad. At least I know you got the concept.
Okay.
Do you got it? Number 6?
Almost there. Hold on.
Yeah.
No, I don't got it.
Okay, so what do you do here? You got
Secant x minus 1 times n. Right?
yep, so it will become n secant x. What else?
And then it'll cross out, right?
I do not know.
-1.
What is -1 times n?
-1n.
Or negative n?
Yep.
What happens to this negative? We'll move up here, right?
Yep.
You had to distribute. What you get?
-n secant x.
What else?
-n.
Yep. And what happens in denominator?
It crosses out.
So which crosser? Let's do
Oh, no.
denominator.
Oh, okay. No, you times it.
So what you get when you times this? Yes.
Secant x squared
Minus
minus
1.
1.
Okay, now the top one. What you say just now? Something cancel.
Yes, you
Which one
cancel
can be? Which one can be canceled?
the secant x.
So what you left?
-4n.
No. What's -1n? Take away 1n.
-2n.
See, you got this.
Well, what about the n in the front of the secant?
There's one plus and one minus.
Oh, okay.
The whole thing cancel out.
Oh, yeah. Okay, yeah.
Can you tell me what is secant square x minus 1 is?
Yes, it is tan squared.
So what happens next? You need to get this. You should know. Don't forget, I need to get this. This is what I need.
You times it.
So we do the
Tan
what?
by tan x. Tan.
We reciprocal it.
Yep.
What is 1/10? So this is, yeah. So this is actually is my -2n times 1/10 square x, right?
Yep.
And this is the reciprocal of what? -2n of what?
Cotangent squared.
Yeah. This one.
Okay, that one was a lot harder.
Not hard. That's not hard at all. Shut that thing off and all right, next. This you get. This is good. What you did on number 7. The top one is correct. What you did on number 7 is correct. You get cosecant square x minus 1. Then you just stop. You're doing it the right way. You just
I know.
So can you tell me what happens in the denominator here?
You times it by sines.
So what you get?
Sine x squared.
1 over
Sine x squared.
sine square x.
Yeah.
Now, can you tell me what can we do with this one?
Yes, you can change that to 1 plus cotangent.
Now, 1 cosecant square x minus 1. So
Yeah,
What is cosecant square x minus 1? You minus 1, so what you get?
Is that
Pythagoras.
cotangent?
Yeah,
Yeah,
just cotangent. Just
Yeah.
cotangent, right? Oh, sorry, I didn't hear you. Just cotangent,
Oh.
right?
Yeah. Oh, you're making me feel like I'm the thing over here. Okay.
Okay, and you still remember what happens to this?
Yep. You times it.
Times, so it used to be divide.
You times it by sine squared.
Okay. All right, close, we finish. Don't forget, we need to get cosine square. So what can we do next?
Change it to
What?
cosecant minus 1.
No. Don't forget, we need cosine square x. So that is an identity changing this without using Pythagoras.
Oh, cosine. No, that's not right. 1/tan?
No. We need to cancel. Do you see that there's a sine square x over here?
Yeah.
So we hopefully that is a cancellation. So that is something we can change with cotangent square x by using the quotient identity. Cotangent is what over what?
Cosine over sine.
And what happens?
The sines cancel. See, yeah, that's where it confused me because I got stuck where the square it is, and then I didn't do the quotient. I didn't.
Do not think that always you see square is going to be.
Does that make sense?
I know. What you think is always you think that's a Pythagoras. Every time when you see a square, you always think Pythagoras.
Yes.
But
That's what I thought.
not,
that's why I stopped right there. That's why I stopped.
Always, not always Pythagoras. You already use a Pythagorean here.
Okay.
So usually you only use it once.
Okay.
You don't use it again, usually.
Okay.
Yep. Usually we don't use it twice. Once you use it one time, mostly you could say, if you look at it, you only use one time. All right, this is really good. This is, yes. All right, now you get, this is correct. What you did here is 2x is equals to the arc cotangent of negative root 3 over 3. This is correct. So now you just need to tell me what is the arc cotangent of negative 3 over root 3 is. Now, before that, this is something I will tell you here, Calvin, is you got this as what? Negative 1 over root 3, right?
Yep.
Okay, I'm just use back this one so it's easy. So I will, okay. Because we do not do arc cotangent or arc secant or arc cosecant, so we can change this cotangent, arc cotangent to become what?
Tan negative 1.
Arctangent. But what happens to this?
It becomes positive?
No.
No.
We flip it.
Oh yeah, square root 3. Okay. Oh, okay. That makes sense. So it'll be okay.
Now, can you look at your unit circle and tell me what angle is this? Don't forget, I want it from 0 to 2 pi.
Would it be
Negative root 3.
5 pi over 6?
And, oh, no.
No,
Not
that's
5 pi. No, 5 pi over 6 is not square of 3. 5 over 6 square of 3 over 3.
Oh, it'll be 2 pi over 3. Sorry.
So what else beside that one?
5 pi over 3.
Okay. Now, because that this is a 2 here, so what you need to do here for Kelvin, you have to do you remember the first question I asked you to find the coterminal angles, one positive, one negative? So you have to find another positive coterminal angle for 2 pi over 3. And
So-
another positive angle for 5 pi over 3.
Oh, okay.
The reason why is because you got 2x, you have to do twice. 2 times. 1 time and then 2 times. If this is 3x, you're gonna do another, you got 6.
Okay, that makes sense.
So what is a positive coterminal for 2 pi over 3?
Is it 6 pi over 3?
No. You add 6 pi over 3. Yes, you add 6 pi over 3 because 6 pi over 3 is 2 pi.
Oh, the 8 pi over 3.
And
11 pi over 3.
so this is all equals to what? 2x. So do you know how to solve for x now?
Divide by 2.
You got your answer, right? You know
Yeah.
how to do it.
Yeah.
So this is the thing I want to point out to you, Kelvin, is if it's 2x, you will do this. You will have 4 answers. You have to do it twice. If you have 3x, you're gonna do it. You have to do another. You have to add another 6 pi over 3 in this case.
Okay.
And then you have 4. You have to do. So the more the more multiple angles you have, the more times you have to do it.
Okay. That makes sense. Yeah, I mean, I was almost there.
The last question here is question number 9 before we go to the calculator piece. This is good. So what you did here is good, but can you tell me what happens when you distribute a -2 in here?
It becomes positive.
So what you get here is 1 minus sine x minus 2 plus
That's,
2 sine square x.
oh,
equals
okay. So
0.
that's where I got it wrong. Okay.
And then everything down here is completely wrong.
Yeah, because of that one step.
No. Not because of this. This is, so you combine like terms, what you get? 2 sine square x.
Yep.
Minus sine x. Minus 1 equals to 0, right?
Yep.
Do not do this, Kelvin. This is a quadratic type.
Yep.
Factoring. This is not factoring. You cannot solve this way.
Yep. So I did it the wrong way. Okay.
You got what I'm saying here?
Yeah, I know where. Yeah.
This the minus is very minor. The major part is this down. Do you know what's the factor for this?
Sine x. And then 2 sine.
Mm-hmm.
Then -1 and 1.
Is that right?
Yep.
So that is correct. So then you solve.
Yep.
So sine x equals to what here?
0.
1.
Oh, yep.
And sine x in this case is equal to what?
1/2.
No. Negative.
-1/2.
What is this answer in this case?
X equals sine -1, 1.
Which is?
Pi over 2.
This one?
It is
Unit circle will help you.
11 pi over 6.
11 pi over 6. Okay, what else?
And 7 pi over 6.
Okay. Yep, that's your answer.
See, I got confused because you know how we have the other one where you can have 4 answers because you plus or minus the
When you take the square root,
Yes, that's why I got
this is
no.
Nope. You can only take the square root if you don't. If you do not have the sine x, if you have 2 sine square x minus 1 equals to 0, yes, then you add 1 and then you divide by 2 and then you take the square root. You see the difference between this problem and this problem?
Yep.
Okay, so if you don't have a middle term, you can do this.
Gotcha.
But if you have a middle term, you have to factor this way. Right. Now let's see your calculated questions.
Yikes.
Don't yikes me. I won't even look at it. Because I don't have a calculator. This one looks good. 47, 36, 27, 22, 360. Okay. I just trust your calculator work. Okay. Is it 4630? How do you get this number?
Don't you do 9.8311 times 4,000?
And then times
pi over 180.
Okay.
Right?
How you get 686 here? I mean, I know what you're doing here so far, but how you get this number? Can you tell me how you get 686? This times this doesn't give me 686.
No, it does not.
Yeah, so my question is how you get 686.
I don't know. I don't remember.
The answer is correct. What do you get when you multiply this? You just did, right? What do you got when you multiply this?
A decimal number.
Yeah, yes, what? Yeah.
It's like 0.1715 da, 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 da.
So what you do?
And then you times it by 4,000.
Yes, thank you.
So I skipped a step.
No, you got it.
No,
So
I know.
multiply by 4,000, what you get?
Bad answer.
That answer, yes. The answer is correct. It's just like, I'm asking you how you get it. You said, I did not know. I was like, oh. So that's the thing is that I want to see how you get your answers.
Okay.
All right.
I just typed it in my calculator, so I just forget.
This is good. A ladder is 10 meters long, lean against the wall for F75 with the ground. How high? Yes. So can you tell me which
X squared minus X squared.
No. I want to find X here. So can you tell me which trigonometric sine, cosine, tangent that use this?
Sine.
Yes. Why I don't see it?
I think I wrote it down.
Sine what? Sine 75 degrees equals to what?
10.
What?
No. X over 10.
So can you tell me what is X and how we solve for X here?
You
Multiply this by
10.
10. Yep. Take out your calculator and this is easy.
See, that's why
You got this right. I don't know why I cannot read what you read. I cannot.
No, that's what I was. See, that's why I was like.
This is what you do, and then whatever you both forget. This is in degree, right?
Yes.
So make sure your mode is in degree, your calculator.
Oh wait, let me change that.
Yeah. So that is the one thing I will point out. Make sure your calculator is in degree mode. Yeah, I want you to do well in this class.
If I get a C, I'm just gonna retake it. So
No, don't be taking it. You're wasting your time. This is a 5 credit. What's your answer you get?
9.65925.
2 decimal place, 9 point what?
66.
That's how you do this. This is not tough. You can do the tough one, but not the easy one. This is tough. You can able to do it. So it looks like what I'm looking that you need to practice, Calvin, is definitely proving identities.
Yep.
Okay. The solving part, I think you can manage a little bit. This one you kind of give up. Graphing is also the other one that I will point out. And also this page.
The easiest one.
But the rest looks good. So for me is, I will want you to practice more on this.
Okay.
The graphing ones, and then the proving ones. Where can you practice the proving one? Textbook.
Okay.
So if you go to your textbook or ebook, you will able to do the 7.2.
Okay.
So if you have, so if you look at, so let's talk about the proving identity first. So you go to the ebook.
Okay, can I ask you, am I doing the worst in the class?
No,
Okay.
you are not. You are not doing the worst. I'm spending a lot of time with you, so don't give up on me yet. I spent almost 3 hours with you today. Don't give up on me. Okay, you're not the worst one. If you are the worst one, I don't even spend 3 hours with you today. You know what I'm saying?
It's just my brain just stops working after like I get stuck.
Looks like your brain is giving up.
Yeah, and
You're
then
frustrated,
like,
and it'd be like,
yep.
so 7.2, 7.2.
Okay.
This is a proving identities. I will recommend you to do a few of this. I don't do the front one. The front one is easy. So do some front one, the beginning one. Also do some back. This is the more down you go, the more difficult it gets.
Okay.
Okay. So this is the proving identity that I will tell you that I recommend.
Okay.
Okay. For the graphing piece, your graphing piece is not in chapter 7, it's in chapter 6.
Yep.
So you go back to chapter 6 in your book, in your ebook or book, and then you go to graphing 6.5. How you graph secant and cosecant graph. You go under exercise.
Okay.
And there is tons of graph to look at this. There was tons of graph that you graph. Okay, see this?
Yep.
From tangent to secant. So again, don't do the front one because the front one is easy. Try to do the one at the back, the one with the parentheses, the one that I suggest you to do. So you know what I mean?
Yep.
So anything in the back one here will be something I would recommend you do.
Okay.
That was the graphing one. Okay. To do this page, this is the graphic we talk about. To do this page, you need to take my quiz out.
Okay.
Okay. Or you just simply write this test on your own. This page. How do you do it? Take out your unit circle. Pick a radian or a degree. Let's say I pick all right, 7 pi over 4. See 7 pi over 4? So I just say, what is cosecant 7 pi over 4? There you go. See that?
Yep.
And then you pick another one, 5 pi over 6, right? Example.
Okay.
Attach one of the 6 trigonometric tangent, whatever.
Okay.
Tangent. And if you want to be tricky, you can put negative on it. You with me here?
Yep.
So this is how I want you to just pick any angles, and don't forget it can be degrees. So you can do like 210. and then put what do you want? Secant, cosecant, tangent, sine, what, pick one, you know what I mean?
Yep.
Sine. And if you want to challenge yourself, put a negative on it. Okay, that will, that will be challenging yourself. So that is how we do it. And then the other one is you do the arc. Remember the arc one?
Yep.
So this time you pick any, if it's arc sine, make sure you pick any y value you got. So it's negative square root 3/3. Sorry, y value. It's negative root 3/2.
Yep.
Just put an arc sine.
Okay.
And then when you do the arc cosine, make sure you take the x value. So 1/2, let's say. Okay. And then when you do the arc tangent, you pick the y over x value. Square root of 3, for example.
Okay.
Okay. This kind, you can actually use your calculator to do it, to check your answer.
Yeah, I was gonna say not on the test.
Not on your test, but I say once you finish doing this, you figure this all on your own. You want to figure out if this is correct. Use your calculator to check it.
Okay.
Your calculator will tell you the answer. And again, watch out for degree or radian.
Okay.
Okay, because like this is going to be radian, this is going to be degree. So make sure you check your answer using. So that will be the one I will tell you to do. So there are three major things. This one that I mentioned, your graphing and your identities proving.
Okay.
Solving, you got it. It's just it's a bit, yeah. The rest, I think you'll be good. So I wouldn't recommend you to practice this. I think you got this.
Yeah, that was, yeah.
And I don't think so. I want you to practice the first page of this. Looks like you get it. The one that really I see that is when you get frustrated with a question, is where your mind stops working.
Yep.
That I can tell. So
Okay,
do not frustrated. Don't get frustrated.
I know.
Do not get frustrated. Why you want to get frustrated?
I don't know. I just feel like
it's not, I mean, it's a test. So
yeah.
Don't get frustrated. Just take it. You can do it. I know you can do it.
I know.
You get frustrated. You got so well. You done so well on the first 2 pages, right?
Yeah.
And then the back is all because you get frustrated and then you feel like, no, this is not what I want to do. The stuff for that. So I would recommend you to practice those again.
Okay.
Right, Kevin?